Hello and welcome back to the channel. In today's session, we're going to understand a concept that often confuses many CAIIB aspirants: Macaulay's duration and modified duration. By the end of this video, you'll not only understand the formulas but also be able to solve any numerical question based on duration with full confidence. Let's begin. Macaulay's duration is a measure of how long it takes, on average, to recover the money you invested in a bond. It is defined as the weighted average time to receive the present value of all cash flows. That means both the annual coupon payments and the final principal repayment. Think of it this way: if you're buying a bond, you're investing money today, and in return, you'll receive periodic interest payments and, at maturity, your principal. But instead of thinking of these as scattered payments, duration tells you one average time point when the money is effectively received back. It's like compressing the scattered timeline into a single number. That number is Macaulay's duration. Before we jump into calculations, let's understand three important terms involved. 0. Cash flow. This is the amount you receive from the bond each year. It includes interest payments, and in the final year, the principal repayment as well. 0. Present value factor. This tells us how much a future amount is worth today. Since money has time value, a rupee received a year later is worth less than a rupee today. The PV factor is calculated as 1 divided by 1 plus the interest rate, raised to the number of years. 0. Present value of cash flow. This is the actual worth of the cash flow in today's terms. We calculate it by multiplying the cash flow by the PV factor for that year. Let's take a simple example to apply this understanding. Assume the Reserve Bank of India issues a bond with the following features. Face value is 100 Indian rupees. Tenure is 3 years. Coupon rate is 8%, meaning you receive 8 Indian rupees interest each year. At the end of year 3, you also receive the principal, 100 Indian rupees. Market yield is also 8%, which we'll use as our discount rate. Now, let's break it down year by year. Year 1. You receive 8 Indian rupees as interest. To find its present value, you use the formula 1 divided by 1 plus 0.08, since 8% is our yield. That comes to approximately 0.926. So, present value of 8 Indian rupees in year 1 is equal to 8 multiplied by 0.926 equals 7.41 Indian rupees. Year 2. Again, you receive 8 Indian rupees. This time, you discount it for 2 years, so PV factor is 1/1.08, 2 equals approximately 0.857. Present value is equal to 8 times 0.857 equals 6.86 Indian rupees. Year 3. Now, you receive 8 Indian rupees interest plus 100 Indian rupees principal, a total of 108 Indian rupees. The PV factor is 1/1.08, 3 equals around 0.794. So, the present value is equal to 108 times 0.794 equals 85.75 Indian rupees. When we add all these present values, 7.41 Indian rupees, 6.86 Indian rupees, and 85.75 Indian rupees, we get 100.02 Indian rupees, which we can round off to 100 Indian rupees. This shows the bond is priced fairly. The sum of the discounted future cash flows equals the bond's price. Now let's calculate the weighted average time to receive these present values. We take each year, multiply it by the present value of the cash flow for that year. So for year 1, 1 times 7.41 Indian rupees equals 7.41 Indian rupees. Year 2, 2 times 6.86 Indian rupees equals 13.72 Indian rupees. Year 3, 3 times 85.75 Indian rupees equals 257.25 Indian rupees. Add them up: 7.41 Indian rupees plus 13.72 Indian rupees plus 257.25 Indian rupees equals 278.38 Indian rupees. Now, divide this by the bond price, which is 100 Indian rupees. Macaulay's duration equals 278.38 divided by 100 is equal to 2.7838 years. So, on average, it will take approximately 2.78 years to recover the investment, not just the coupon, but the entire present value of all cash flows. Macaulay's duration tells us when we get our money back, on average. But what if interest rates change? How sensitive is the bond's price? This is where modified duration comes in. It tells us how much the bond price will change for a 1% change in interest rate. The formula is simple. Modified duration equals Macaulay duration divided by 1 plus yield. In our case, equals 2.7838 divided by 1 plus 0.08. Equals 2.7838 divided by 1.08 is equal to 2.5785. This tells us, for every 1% change in interest rate, the bond price will change by approximately 2.58%. And there's a negative relationship: if interest rates go up, bond prices go down and vice versa. So if interest rates fall by 1%, bond price increases by 2.58%. If interest rates rise by 1%, bond price falls by 2.58%. Macaulay's duration gives us a time frame. Modified duration gives us price sensitivity. Together, they help portfolio managers, banks, and risk officers understand how vulnerable their investments are to interest rate changes. So next time you hear about bond portfolios or market risk, you'll know duration is not just about time, it's about timing and sensitivity. Make sure you practice this with a few more examples, especially changing the yield or coupon rate to see how duration behaves. If you found this lesson useful, don't forget to like the video and subscribe to the channel. I'll be covering more topics from CAIIB with this practical, step-by-step approach.